Okay, on this ready section of our homework, they're giving us an input or an x value, like this x is -3, and they want the output. So let's go take a peek at this graph. I'm going to zoom in here for you. And let's see if you can start. After this first example, 1ABC, I want you to pause the video and see if you can try a couple on these own. So let's go on this graph here to back 3. So 1, 2, 3. It's this dot right here. And so notice how that dot is at the coordinates -3, 0. And so that means that if they gave me the -3, they just want the 0. Given the input, get the output. Hang on, let me go down to a lesser font in a different color. There we go. F of -2. So start here and go back 2 and then follow it down. My function's down here. The coordinate here is at -2, -1, 2, 3, 4. So if they gave me the -2, they want the y value of -4. 0. I'm going to go 0 and then follow it down to the graph. 1, 2, 3, 4, 5, 6. And then 2 is 0. So given the input, get the output. Now pause the video and you go try a couple, see what happens. Okay, g of 0. Ooh, that one's a hard one. I hope you can see that it goes down there to -3. You might have to zoom in on that one to see what I mean. This one goes now next to g of 2. Go out to 2. See how the coordinates are 2, 5? So they told me the 2, they want the 5. G of 3. G of 5. How'd you do? H of -4. H of 0. H of 2. H of 4. Okay, seriously, pause the video and try this one if you haven't yet. R of -3. R of -1. R of 0. Hey, that's just the origin. R of 5. There it is. Input, outputs, how'd you do? All right, next on this section, it's giving you a context-based piecewise function. So it says Isaac lives 5 miles away from his school. So notice that we're traveling here for 5 miles. School ended at 3 p.m. and Isaac began his walk home with his friend who lives 1 mile away from the school in the direction of Isaac's house. Isaac stayed at Tate's house for a while and then started home. On the way home, he stopped at the library, then he hurried home. Then the graph at the right is described as a piecewise function, and it shows Isaac's distance from home during the time it took him to arrive. So first of all, how much time passed between school ending and Isaac's arrival home? So notice at the bottom, we've got our time. School ends, arrive home. What do you think? All right, 3.75 hours. See how it tells you right there that that's a 3.75? Well, what does that mean in terms of hours? It's 3 hours and 45 minutes, in case you cared. How long did Isaac stay at Tate's house? School ended at 3. That's right here. Isaac began his walk home with his friend Tate, who lives 1 mile from home. He stayed at Tate's house for a while. So this little flat function is Tate's house. So how long did he stay? From this point to this point? Do you see how that's 2 hours? Go take a look at that and see if you can understand that that's how I got that 2 hours. How far is the library from Isaac's house? How far is the library from Isaac's house? So this right here is the little library. And so here's distance. And so that's 1.5 miles. Where was Isaac 3 hours after school ended? You see that that's when he was at the library. Use function notation to write the mathematical expression that says the same thing as question D. So f of 3, he was at 2 miles. F of 3 equals 2. When was Isaac walking the fastest, and how fast was he walking? So you're looking at this point for the steepest part of the graph, your steepest slope. So notice that this is going down 2 and over 1, and this one's going down, this goes about down 3. This is down 1.5, sorry, each line is a half. So this is technically down an hour and over a half mile. So down 1 hour, over half a mile. And then this one is down 1, 2, 3 spaces, or a 1.5, and over a half mile. So notice how this one is steeper. You might have just been able to see that from the picture anyways than the original. So when was he walking his fastest? That's when he was walking from the library to his house. And that's from 3.7, from 3.25 to 3.7. Actually, I'm going to write this in interval notation. This is the interval which he had the steepest slope, and the slope happened to be negative 1.5 over 0.5. Yes, you could divide that in and get me a more simplified answer, but it's fine just to leave it like that. And so Isaac was walking the fastest from the library to his house. Maybe at that point he had stayed too long at all the places and his parents were getting mad, so he had to hurry home. Anyways, that's it. That's a context-based piecewise function. How'd that go for you? All right, next one, we've got 2 pieces. Piece number 1, little flat line, and piece number 2. Piece number 1 work. What's my slope of that nice horizontal line? That slope is 0. And any point on this line, I'm just going to grab this guy right here. So it's out 2 and up 3, and that can be used as my x1, y1. This is a linear function. In fact, it's just a horizontal line with no slope. So for piece number 1, here comes my equation. It's y equals 0, x minus x1 plus y1, or everything in the front zeroes out and it's just 3. There's piece number 1. Let's go do piece number 2. I'm going to go over here to the side. Piece number 2 has a slope going up 2 over 1, up 2 over 1, slope is 2. And we're going to pick any dot on that line. So we're going to pick out 1, 2, 3, up 1, 2, 3, 4, 5. I just literally picked a random x1, y1. I can choose any x1, y1. So let's go plug this into the point slope formula. Y equals m, x minus x1 plus y1. And that's my piece number 2 function. So now I've got my 2 pieces. I get to go write my piecewise function. F of x equals big bracket. The first function, piece number 1, is just 3. The second function is 2, x minus 3 plus 5. And then I put little tiny commas for the domain at the back. The domain of the first one is from 0 to 2. And the domain of the second one is from 2 to infinity. Go see if you can understand where those numbers came from looking down at that x-axis. I'm going to include the 0 here with the first one, And then I'm going to say that the second function starts at 2 and goes on. Oops. So I'm going to put this little bar here to include the 2 as well. There it is, my piecewise function. F of x equals 3 from 0 to 2, and f of x equals 2 quantity x minus 3 plus 5 from 2 to infinity. Next one has 1, 2, 3 parts. So here's little tiny piece number 1. Here's piece number 2. And here's piece number 3. They are all linear functions. Okay, so the first one, none of these are horizontal, by the way. So none of these are going to be like that horizontal line with a 0 slope. So go ahead, pause the video, and go count the slopes of all 3 of these. And go get me an x1, y1 for all 3 of these. Remember, it can be any point on the line. Okay, unpause. Let's see how you did. Let's see. Up 1 over 1 is just a slope of 1. Piece number 2. Whoa, look at that slope. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 over 1. Yikes. That's a big slope. And then up 1, 2, 3, 4, 5 over 1. I'm going to pick any point. I could pick 0, 0. I could pick 1, 1. Any point, I'm going to pick 2, 13. Any point on the last one, I'm going to pick 1, 2, 3, 18. I can't even see those little numbers. Can you? Did I get those right? Here we go. Let's use a different color. Okay, the first function goes y equal m, x minus x1 plus y1. How'd you do? Y equals m, x minus x1 plus y1. Piece number 2. And last, y equals m, x minus x1. Squeeze it in. There's my 18 plus y1. Those are my 3 functions. We are also going to need the domains. And I'm going to run out of room. So let's go write this up top. All right, f, this is number 7 way over here. F of x equals big brackets. Write the first function, x minus 1 plus 1. Leave space for the domain. Second function, 12 times x minus 3. Sorry, that's a 2. Sorry. Don't be mad. Okay, and then plus 13. Leave space for that domain. And last, 5 x minus 3 plus 18. Now we need to go do those domains. This first little part of the function, see it? Boop, that little tiny line, it just goes from 0 to 1. What about the next part? I'm highlighting green. This goes from 1 to 2. Oops, sorry guys. 1 to 2. And last one, you got it. It's going 2 to 3. Notice that since this is a continuous function, one leaves off where the other one starts and so on and so forth. We want to include the 0 with this one. We want to include the 1 with this one. And we want to include the 2 with this one. And since the end is a closed dot at 3, we're going to include that final one since the piecewise function is done. All right. There's my full piecewise function for number 7. How'd you do? Okay, last but not least, in class, we already did this guy. We already did this guy. And we already did this guy. So that goes y equals negative 5/4 x minus 0 plus 0. What? That means that just goes away. Okay, so you're just supposed to finish 10, 12, and 13 on your own that we didn't do in class. Pause the video and try it. Okay, how'd you do? Did you get it? Three minus a negative 1. Oops. That's going to become 3 plus 1. Are you okay with how I got that slope? Now this is my x1 and this is my y1, so I go x minus a negative 1. See how the sign changed there? Careful with number 12. Make sure you understand all that, or see if you want me to show you in class tomorrow. Here comes our last one. Oh man, they're bringing out all the negatives on this last one. 18 plus 9 over 5 plus 1. 27 over 6. Yikes. 3 goes into the top. 3 goes into the bottom. 9 halves. Woo, that one's fun. And then x minus negative 1 plus, nope, minus 9 is really just going to become x plus 1. X minus a negative 1. Okay, how'd you do on those? Homework is done. Good job.